I have a much deeper appreciation for quote unquote the bureaucracy after having been on the other side for quite a bit of time. And it's easy to throw rocks at the castle and say, they're just slowing us down. But in reality, policy is put in place to try to let things go as fast as possible without having to dramatically walk things back and play damage control, because that will ultimately slow progress down in a really serious way.
Erum, what's going on?
Oh, just ordinary life in the United States. We had our democratic election and a decision was made. So the decision happened and it remains to be seen what happens after January 25th. But all I'll say is our country's divided and hopefully we are on a trajectory of good things, but we just don't know what's going to happen. And that's all I can say. That's all I can say. We don't know. I come from a lot of worlds. I have family in the suburbs of Pennsylvania. I have a lot of friends there, and they live on both sides of the train tracks, So I respect everybody, and I'm just trying to make sense of things. And I don't know, it helps me keep calm because I can see some reasons why people make decisions. That's all I'll say.
Yeah, I mean, you said it earlier, hate the player, not the game, which I think is a good approach, which is the approach that I'm going to take. Hate the player, not the game. But hate is too strong of a word for me right now. So we're just going to watch this thing play out. I think we're lucky. We work in the biotech industry. We have this podcast is about growing everything using biotechnology. There's more opportunities than there ever were. And many of those opportunities started before the Biden administration. During the first Trump administration, biotechnology is seen as a national security issue. So I want to continue to believe that what happens with this administration will be positive for us in the biotech industry. But if you didn't win, and if you really want to talk it out or you need to vent, feel free to text us or email us. You know how to get a hold of us. We're happy to talk to you. I was away this weekend. Erum, you celebrated your birthday. Happy birthday. But while I was gone, I got text messages that Prospect Park was on fire. You were living that. You were here. What was going on?
Yeah, it was pretty intense. I mean, I woke up on Saturday morning and I saw these text messages of pictures of our beloved Prospect Park that were on fire. And it's a place that I go daily for a run or a walk. You hike around there and walk around. It's the lungs of at least South Brooklyn. It's such a big park. It was an isolated incident, but it was interesting because at the same time, there were fires in New Jersey, in Catskill Mountains. And those were brush fires. I believe they were caused by the dryness in the air, the heat, a confluence of things. I think what happened in Prospect Park was from fireworks. When we woke up and opened the window on Saturday morning, it smelled of smoke. It was a hard, burnt smell that we had to close the windows, turn on our air purifier. If you don't have one, I recommend people get one. And we did end up walking outside. The air quality was really bad. Now it's clear. It's been a few days since all these fires happened. But you were up in the Catskills during this time.
Yeah, actually, I was in the Adirondacks, but I know that one of the causes was we have not had any rain in New York State for the longest period. We've not had rain in the fall. So that not only affected Prospect Park in Brooklyn, but it made things so dry that there were also fires in New Jersey and in the Catskills.
I think the cause of the Prospect Park fire was because of fireworks.
And actually what they're saying, it's because of vagrants had a fire going.
Yeah. Why vagrants? But anyway.
Well, because there is like a homeless camp in there, which I never really noticed.
But it was a mixture of both. They had a fire. They could have extinguished it. But it's the fact that there was very low humidity and no rain just escalated the situation because of the climate conditions.
Yeah. Yeah. I don't know. All that is environmental news, not really great. But you had mentioned a book that I think you're reading, The Wildlife of Our Bodies. Let's talk about that for a minute.
Yes, it's an incredible book by Rob Dunn. And we'll put that in the show notes. The book is about the human symbiotic relationship with the natural environment, whether that's different microbes or parasites or worms that humans have been exposed to for thousands and thousands of years. But more recently, we have been isolating ourselves from the natural world through our built environment, through our homes, through our office buildings, where we spend 90% of our time. You and I are indoors right now, and we're going to go on the computer and we're going to do our work. And we live in the city. So that's in itself a built environment that's far from the natural world. That has been taking a toll on our health. There's a lot of studies and research that say, hey, look, we have a lack of microbes. We have a lack of worms that were beneficial. We have a lack of parasites that were beneficial to us to help regulate our immune systems and have a very symbiotic relationship with our health and the way our body works. So now there's this dysbiosis happening, and how do we change things? In the book, I'm still reading it. I'm about 75% of the way through, but they talked about this professor who had thought this was such a fascinating story. This professor looks at how animals die, and specifically when it comes to the predators and prey, and how over time, prey responds to predators and they evolve certain features to protect themselves. So they talked about, for example, mollusks or clams or mussels. So in the middle, they have soft bodies, and then they have a shell. And they are in special locations to try to hide from their predators, which oftentimes are crabs, for example. Over time, what mollusks were doing was to protect themselves, they ended up creating harder, spikier shells, and they clasp themselves shut, so it's harder for crabs to open them up. And then crabs also then evolved to try to open prey. The claws are stronger to open. So it's this very interesting dynamic of evolution between predator and prey over time. So he's done this, and he's been studying seashells. But the crazy story of this is this professor, his name is, I think he's Dutch, is probably Gerard Vermeij. He has been blind since he was 3 months old.
Crazy.
And he's become this professor. He was a MacArthur Fellow. He got the Guggenheim Fellowship. He's a very accomplished professor. And there's also a story of senses. He couldn't see, so he had to feel these seashells over years and years and years of his study and research to understand how they've evolved. And he used a sense of touch and taste and smell, where humans have evolved to become very visual people. That has often muted some of our other senses. So it's just a beautifully written book on how we are the way we are in terms of humans, how we are the way we are in terms of life, if we associate ourselves with different animals and different microbes, looking at evolution. So highly recommended. I love this concept of symbiosis and dysbiosis to be able to say, hey, look, we all need each other, all forms of life.
We've evolved together. So that's super interesting. I mean, those kind of symbiotic relationships, I think, are fascinating. We have talked about fungi or mushrooms a lot on this podcast in the past. There is this pandemic that's happening globally because there's this fungus, and we live around fungus all the time. What happens is humans react to things when things are out of balance. And it's interesting that you say we live in these built environments, but apparently there's this new fungus, it's C. aureus, that has been affecting people all over the world. I don't know if it's constituted a pandemic, but these fungal infections are pretty serious. So we lived through a pandemic already. Hopefully we won't have to live through a fungal pandemic, because that is like the premise of The Last of Us, which,
what? This is just like insane to me. Like, oh my God, we should probably look more into this.
So this brings up this bigger idea of biosecurity, which you've mentioned a couple of times. And I think that's a good introduction to our podcast guest, who is Alexander Titus, a commissioner on the National Security Commission on Emerging Biotechnology. It's worth saying that the National Security Commission on Emerging Biotechnology is a nonpartisan commission, and they're focused on all biotech topics upstream. So they might be talking about building in weird new environments, whether that's here on the planet, maybe that's in the jungle, under the ocean, or off planet. They're trying to find new ways to protect existing infrastructure. They're looking for ways to advance healthcare, and they're interested in maintaining robust biosecurity all over the US and all over the world. Biotech has a lot of promise. I've met Alexander Titus a couple of times. We've been trying to get him on the podcast for a while, and I'm super excited to have him on. Is there anything that you should mention at this point, Erum, before we get into the interview?
No, I mean, we're saying Alexander Titus. He likes to be called Titus, so you'll notice that. Very interesting background, and it's exciting to have Titus representing the National Security Commission on Emerging Biotechnology. And let's let Titus take it away.
Awesome. All right. Dr. Alexander Titus, We are so happy to have you on the Grow Everything podcast. We've got a lot of stuff to cover today. What's going on? Where are you today?
I appreciate you having me. Today, physically, I'm in Denver because it's ski season starting and the snow, I'm doing my snow dance.
Oh, right on. Yeah. Sounds good. So for people who don't know you, you are a commissioner on the National Security Commission on Emerging Biotechnology, the NSCEB, which is an advisory board to the United States Congress. You're wearing your t-shirt.
Yeah.
Can you give us the who, what, and why of the NSCEB in 3 or 4 sentences?
Yeah, for sure. It is a mouthful. We love to joke about it. So I always just call it the commission. So the commission is a bipartisan group that was stood up. So we have 11 commissioners. 4 of our commissioners are members of Congress, 2 Republicans, 2 Democrats, 2 from the House, 2 from the Senate, and then 7 other people who are experienced in government, industry, academia, biotech policy, et cetera. And our job is really to advise Congress on what does it mean to write good legislation for the future of biotech in the US, and then by extension in partnership with a lot of our partners and allies around the world. So we talk to experts, think deeply about these issues, debate fiercely about these issues so we can come to really good decisions on how we can make recommendations to Congress about where we should be going from here.
Yeah, that is amazing. Wow, that's quite the position that you have. I want to know about debating fiercely in Congress. I've seen some things on C-SPAN, but I'd love to see videos of this. You've been a proponent of biosecurity and this understanding biology and how it can be used in industry. And you are famous for walking into the Defense Department meetings with the Biomason brick. And so our listeners are familiar with Biomason. We've had Ginger Dozier, founder of Biomason, on here a few times. But can you tell us a little bit of that story? Why did you bring the Biomason brick in the Department of Defense? And what kind of impact did it have on the meeting?
Yeah, so I always use a joke that the Pentagon's a rough place. You always got to carry something with you. But in reality, I had the fortunate privilege to be the first person to lead the establishment of an enterprise strategy for biotech. I was the assistant director for biotech at the Department of Defense. And this was in 2019 when I started. And the Pentagon could barely spell DNA, let alone understand why it was important for everyone. And when I talked about biology, biotech, you could see little green blocks of jello shaking around in people's head. That's all they could think about. It's like, biology? What? So bringing the green goo to the Zoom and boom people is what I said my job was. And so I wanted to make it tangible. So I found the thing that was the most appropriately tangible product, because people want capabilities and products when you're working the Department of Defense. And the Biomason brick is a really great example. All of the same kind of performance standards and everything. It's just a brick. It was a literal drop-in replacement from thinking brick to brick. But this is produced with biology, doesn't take the same amount of energy, doesn't have to be fired. It can be set at room temperature. You can have it in a forward deployed environment. So that's why I brought it around. And it also did make some really interesting icebreakers. You walk into a room and put a brick on the table in a suit, and everyone's like, who is this guy? Why is he here with a brick? But it did. And it's all about the whole point of your podcast is science communication. And how do you explain these things and contextualize them in a way that is relevant to the people who are trying to consume that information? And so that's really what it was, is how do I come up with a product that resonates, that says, no, we're not talking about something crazy and out in left field. We're really talking about alternative ways to get the resources we need. And then we talked about a lot of other interesting things. That led to discussions of, can you build growable runways? The Air Force and DARPA were working on this with Biomason and others to say, yeah, let's build growable runways. Let's see if we can spray this down and harden the surface. And then people started having those aha moments like, oh, I can land a helicopter on sand because now it's hard enough that I could actually touch down on it. Things like that. And it became a big joke, and I became the brick guy around the Pentagon. But whatever it takes to get the point across, I guess.
Yeah, no, I think it's really good that when Erum and I were coming up with the questions, I was like, you got to ask the brick question. I mean, you and I have kind of known each other for a while, and that story stood out in my mind. Yeah. And I just attended the BTO listening sessions up in Boston a couple of weeks ago. And to me, it's fascinating where they go from, hey, we've got all these people from industry in this room. We want you guys to understand what we're looking at. And it ranges from things like, how do we keep our warriors safe, to how do we go into a location, use the existing materials that are there, maybe do a biotech process on them to create, I don't know, buildings if we want to say, if that's what we need. But then how do we also leave the place so it's better than when we got there? And so it's really interesting that DARPA is thinking that way. I don't know if the Defense Department is thinking that way, but anything that we can do to get people to think about these technologies in a positive light, I think is really useful. Now, you're also the founder of Bioeconomy XYZ. You started that publication, and what were the key trends that got you interested in doing that? What did you want to highlight to the public?
I started Bioeconomy XYZ in May of 2020 because I had just left my job at the Pentagon when the pandemic started, because we were all dealing with things at that time. The thing that I really realized when I was in that role in government was that there were so many really brilliant scientists who were doing things that were highly relevant, but either didn't have the platform or the experience to be able to communicate it to an end user who they don't care if it was made with biology. They care it does what they need it to do. Bioeconomy XYZ, the entire point was to provide a platform for people to learn how to write and express the impact of biology in a way that was visually appealing, interesting to read, and things like that. And it thrived for a long time. And then just so happened that the person who was helping me run it ended up working in government and doing other great things. And so it sunset, but then I just started a new newsletter called The Coevolution: Tech Policy in Our Lives, which is kind of an evolution of that, thinking about how does technology and policy interface in a way that both sides can understand each other.
Wow, that's cool. Yeah, I'm definitely going to have to check that out. We'll put that in our show notes as well, so our listeners can access that. I would love to learn a bit more about it. Your experiences are incredibly interesting. Your work spans diverse areas, so academic research, government strategy, corporate innovation. So can you help us understand what experiences have uniquely prepared you for your current work on the commission? What are the things besides taking bricks and bringing them to Department of Defense meetings?
Yeah. I think it's safe to say that of the 11 commissioners, I'm the only commissioner that has worked in industry, academia, and government, and been a practitioner to try to bring biotech to bear for national security purposes collectively. And so we have commissioners that are really deep on federal finance, or really deep on legislation, or really deep in intelligence, or really deep in building big technology companies, or being innovators in academia and entrepreneurs. I am not as deep in any one of those things. And I am the living embodiment of the intersection of these technology areas in the respective domains as well. So that to me gives me a lot of insight into, actually, this is exactly the same thing we do in industry. We just call it something different. Or government. Yeah, it's all the same. We just have slices and dices. And one of the cultural differences that I often highlight for people is that a lot of times government people work, there's no profit motive, there is public impact motive, but they also don't realize that everything they do needs to be funded. And industry is the same thing. It's like, why is everything so slow? And it's like, well, because we're using dollars, big amounts of dollars to move around and try to have influence on the industry. Or academia, or you say, hey, we're going to start a whole funding program out of the NSF or NIH or DoD. That shifts whole industries. And so that overlapping perspective is really useful. And so I can connect dots and then ask my colleagues, how would you do this? If you were receiving this memo from Congress, how would you have responded? And they could say, well, we would do it this way. We'd ignore it that way. We'd have all kinds of interesting approaches. There's too many good things to do for me to do any one thing. It's, my greatest flaw is I'm interested in everything. And that actually has been super helpful, because a lot of the ways we think about how biology and biotech is impacting national security and industry and things is not actually just biology. It's biology to produce a chemistry that you turn into a material that you put on a tank or a body armor or clothing. And so there isn't one vertical in any one of these workflows.
And do you think that people, veering from our questions, I keep seeing these quotes. I feel like I see them regularly. It just must be because it's a message to us in general that the biggest breakthroughs that are going to happen in any industry are really going to be much more about convergence of industries or outsiders looking at an industry. I mean, we're seeing the impact of AI on biotech. The guy from Anthropic, the CEO, just wrote this long essay, and on the biotech side or science side, he's like, we can expect to see 50 to 100 years acceleration when it comes to discovery over the course of 5 to 10 years. And Erum and I were just talking about it because we're like, yeah, well, it's easy for him to say that because he can just predict it from the AI side. He's not really having to physically do the work. But do you think that people on the commission understand the impact of convergence of all these technologies converging together to impact biotech and how that impacts all other industries?
Yeah. Yeah, we talk about it all the time. The AI and bio conversation obviously dominates a lot of airwaves and a lot of times, and we spend a lot of time talking about that. That happens to be what my technical background is, the AI and bio interface. But we also talk about lab equipment, manufacturing equipment. That's electrical engineering, chemical engineering, mechanical engineering. We'll work across the board. And then they talk about energy and food and ag and industrial and how those work in each of those. But I think that we are going to see, Denise, personally speaking, I think we are going to see a massive acceleration in science. I actually funded a workshop when I was at the DoD to explore this concept of the Nobel Turing Challenge. So the Turing Challenge is when an AI chatbot is indistinguishable from being a person or a chatbot. The Nobel Turing Challenge is the idea, is it possible to create a fully autonomous research lab that can do Nobel quality scientific discovery on its own? And then that has lots of implications, both good and bad, benefits and risks for what's possible there. But there are companies working on this now. We have these large, massive foundation models that are being much better at doing scientific understanding. So I think that we are going to see leaps and bounds. And I think that a good example of that is AlphaFold, that everyone's familiar with and talking about, and they just won a Nobel Prize for their work. But in reality, a problem that has been studied and thought nearly impossible to solve for decades, 50 years, was computationally predicted seemingly with the release of one model. Now, it's still to be determined exactly how much impact that has, because what you're saying, Karl, you have to actually do it in the real world. That's the hard part. At this point, predicting design is going to become trivial. You could argue it already is, but then building it, that's a much harder problem.
Yeah.
Yeah, absolutely. I saw recently that there was a kid who made a fusion reactor prototype for like $2,000 in his bedroom.
Yeah.
I don't know which one he used. Was it Claude or Perplexity? I don't know what he used, but just being able to have that conversation with AI and know what types of things he needs to build it and then actually do it in an intelligent way and making sure you're troubleshooting. And it was very impressive. And I think the kid was like in college or maybe younger.
Yeah. Yeah. But I have a lot of conversations on both sides of the benefit risk equation.
Mm-hmm.
And when people have pushback again, well, we're not going to have to think anymore, or things like that. People said that about the calculator, but I actually carry around an anti-electricity advertisement from 1900 because there's this image where power lines is this skull and spider attacking people. And there were people who were against electricity when it was really coming around. We have to do it responsibly, no doubt. But we also are seeing a lot of the similar, it might be accelerating, but we're seeing a lot of the similar conversation around pushback of technology progress because it's scary and it's the unknown.
Yeah. Yeah. That usually happens with the scary unknown. And then all of a sudden it just flips when people just turn on the switch. They're like, oh, that was easy. I don't have to light candles anymore.
Yeah, exactly.
But for our listeners and just in general, what should they know about emerging biotechnology? Because this is what the commission's focused on. And when it comes to biosecurity, how does that play a role in emerging biotechnology? And this is something that we've talked to some of your colleagues about in terms of what is biosecurity, how you define it, what should people know about it? Because I think there's a group of people that see it as pathogens and warfare. There's another group of people that think of it as preserving the environment and conservation. So tell us more about emerging biotechnology and especially with regards to biosecurity.
Yeah. So to a lot of this conversation, we're also talking about this convergence. So the authorizing language for the commission actually says emerging biotechnology and related technologies, because biotechnology doesn't happen in a vacuum, and computing and electrical engineering and all these things are involved. So the traditional definition of biosecurity really is around public health and pathogens and things like that. But our understanding, our definition of what biology is and can do is changing. That's what bioengineering, CRISPR, all these modern tools, we're unlocking an entirely new domain of what you can do with biology. So when I think about biotech, I think about it in two categories. One, where biology is the actual product. So this can be a biotherapeutic, or it can be an infectious disease or something like that, where the actor, the thing that does the action, is biotic, biology. And then there's abiotic, where you use biomanufacturing to produce a product that is not biology in the end state. So whether this is doing nanometallic templating with phages or producing a chemical, you have different considerations for how you think about this in a biosecurity context. But no matter what, especially in this emerging biotech area, I think of it a lot as products that have been engineered in some capacity. We think about if you engineer a microbe to do manufacturing, if that microbe gets out into the environment, what is the impact that it has on the environment? Even if you didn't have the intention for your product to be biology, you still have to think about the biocontainment and the responsible manufacturing practices that go into those kinds of things. It's even more so when your end product is biology. It's different when you're thinking of like an mRNA vaccine versus an engineered microbe for bioremediation. So there's different levels of containment and different levels of scrutiny that must go in as you think about whether or not you're releasing these things. But emerging biotech, in the way that I use the definition, it's really synthetic biology, genetic engineering, things that have been engineered to do what it wasn't naturally designed to do, but way more precise than we have ever had the opportunity to do in the past.
Hi, a quick shout out to our sponsor, Messaging Lab, the force multiplier for biotech. Your biotech company is making the world a better place. You know that, we know that. But does the world? There's a big reason why some biotech companies attract investors, sign up customers, and get attention. That reason is strategic communications. At Messaging Lab, we translate complex science and economics into compelling narratives. And we have done that for the most successful biotech companies across healthcare, agriculture, personal care and beauty, materials, and the list goes on. We're here to make sure your ideas not only get heard, but resonate with your audience. So if it's time to amplify your company's voice, visit messaginglab.com to explore how we can elevate your story and grow your business.
And is that how you think about biosecurity? Because you said the traditional definition is public health. But when we have talked about it, it's not just public health, it's also engineered organisms that potentially have an impact on human security.
Yeah, yes. But I think that the broad sense of public health, there's not just wear your mask because COVID's happening kind of sense of public health. Food insecurity, pandemics for food is a public health issue. Pandemics for animals is a public health issue. Environmental degradation in our natural habitat, that's a public health issue. So I guess it depends on the scope of how you define these things. And so that's how we think about it in the context of food and ag, energy, industrial. Each one of these domains has massive benefits that we can be building new products and unlocking new markets and bringing new things to people who need them. And they have vulnerabilities and areas that we need to pay attention to, because there's just as much concern about engineering a wheat virus that eliminates our wheat supply as there is for the kind of viruses that go through our livestock. I'm saying virus, but it also could be bacterial, fungal. There's lots of concern and conversation of any of the microorganisms that go into that.
Yeah.
Yep. So I wanted to speak to you about a company that you've been affiliated with, which is very interesting. So it's Colossal Biosciences. This company has worked on very high impact, ambitious projects, for example, de-extincting the woolly mammoth. So how do you approach balancing the promise of ambitious science, which biology can afford, especially with the tools we have now, with the ethical and security concerns that you've mentioned earlier? How do you balance the big vision with what is practical today and what we need to do in order to protect human and life in general?
For me, because I am an optimist, I'm a glass half full kind of guy. There's not a lot of us in the security world. Usually you're a glass half empty kind of person if you're worried about security, but I love my glass half empty people. The way that I think about it, let me take a philosophical step back, because a lot of the concern is coming from now it's easier to engineer biology, and bad actors could potentially engineer biology in a bad way. But a lot of these big ambitious projects are pushing the limits on what's possible and extending how good we are at engineering. I like to think of it as if we have all of these potential routes for scary things, the best way to handle it is to be so good at using biology that we can actually come up with some kind of response or countermeasure or something, remediation to said scary thing. And so that's why I love to work on these big, ambitious projects and this actually gets back to the bioeconomy XYZ and why that was founded and everything as well. Since the Human Genome Project, we haven't had a lot of those big, grand, unifying challenges in biology. And the community talks a lot about like, what's our space race or things like that. I was drawn to Colossal because de-extincting the woolly mammoth is a very tangible, almost visceral example of what we could do, because you can imagine fur, you can feel fur in your head. You've pet big fluffy dogs, things like that. You know what elephants are. So the idea that modern science can bring a species back from extinction is captivating. It is a story that really captivates. But in reality, what it's doing is creating such ambitious goals that we have to, I say we, I'm no longer there, but the company has to advance science to do it. And so this is true whether it's Colossal or any of these other ambitious projects. Same thing with all these companies doing robotics. I'm just blown away with what we can do with robotics nowadays. You have to actually change the state of science to achieve some of these things. That's what I think is so wonderful about them. And we actually at the Commission talk a lot about what are our grand challenges? How can we help foster a grand challenge in biology and biotech responsibly, but still to completely move the needle on what is possible? And my dream is that biology becomes so predictably engineering that it's an electrical engineering analog. I can do exactly what I want when I want, reproducibly. And then that also gives us the opportunity to say, all right, well, here we have a new flu variant. We can create a vaccine much more easily now because we're so good at doing that kind of engineering. And so that's why I work on these big, crazy things. You have to be a little crazy to work on these big things. And so your colleagues are just more interesting.
We love Colossal. Like you were saying, that it's such an ambitious project that other science has to be done in order for it to happen. And we had Ben Novak of Revive and Restore come on the podcast and talking about de-extincting, but it's also de-endangering. There's a lot of animals that are endangered. So how can we use the sciences that Colossal and these other companies are doing in order to protect some of these animals that are about to go extinct? How do we look at that? We need ex vivo wombs. We need other types of things to help with these animals. So that's really cool. I just think those ambitious projects can help tell the stories, but then also be the North Star. I love that way of thinking.
Yeah. And then we at the Commission think, okay, these things are happening and we want people to do great things. How do we provide the right incentive structure and guardrails so that can happen for public benefit over time? We grow the net benefit rather than the opposite, whether it's economic productivity or all the wonderful things we can do with health and food and all that kind of stuff. So the Commission is made up of commissioners, and I've talked about them, but there's also an amazing staff of 20 to 30 people who have talked to everyone in the industry. And I'm exaggerating a little bit, but as many people as possible, hundreds and hundreds of people, both across industry, government, and academia, to get that collective wisdom of what's possible today, where do we need to go, that kind of stuff.
Yeah, I wanted to just make a comment for our listeners who maybe don't know about Colossal, and you can correct me on this, Titus, but the idea of bringing back the woolly mammoth is, yes, absolutely about driving the science forward because it's a very complicated thing to do. But there also is an environmental aspect to bringing back the woolly mammoth. The way I understood it is the reason to bring back the woolly mammoth had to do with grazing in the tundras, and then there was supposed to be an environmental benefit to that. Is that about right?
Yeah, that is the theory and the pitch. We're a long way from seeing whether or not that's reasonable. But again, big, ambitious dreams and trying to have big, ambitious impacts.
Yeah. You mentioned you've been in different sectors. You have this unique experience that you bring to the Commission. But what are some of the lessons that you've learned going from DoD to Colossal to now the Commission, and then also starting these different publications?
My number one guiding North Star is to do hard things with cool people. The reason that I think that's so interesting is I've never had a job that existed before I took it, because I've found that the most interesting areas are opportunities you couldn't predict and that you didn't know about before. When we're growing up, people say, what do you want to do when you grow up? What do you want to be when you grow up? What I want to be when I grow up doesn't exist right now. So I'll let you know when it happens and when I'm doing it. My number one lesson in all the moving between these cool things is that opportunities come up that you will never expect. And then in retrospect, they intersect in ways that you couldn't have predicted as well. So like I was saying, my unique contribution to the commission is having worked across so many of these different industries and verticals and things like that. I wasn't omnipotent. I didn't have this Babe Ruth style approach where I pointed out in left field and said, someday I'm going to be a commissioner on the National Security Commission for Emerging Biotech. So these are the 3 things I need to do to get there. No. In reality, people call me now because they say, we want to try and we don't know anyone dumb enough to try it. So you want to try it, Titus? Yeah. Time and time again, there's so much of it involves failing at something, but I don't really believe in failure. I believe in just a whole bunch of not yet successes. Edison, he was famous for saying like, oh, I haven't failed 10,000 times. I just found 10,000 ways how not to build a light bulb. It's really true. And it's not sappy. Keep working on hard things and you find out that they really have impacts over one. My favorite book that really resonated from me was a book called Range by David Epstein, which talks about this exact concept of bringing ideas across fields really has innovative impact. And that's actually how we spend a lot of time with the commission talking about how do we figure out how things that are happening in one industry, we can bring them into another, or best practices from government. How do we help incentivize some of those best practices in industry and vice versa? So it was a long-winded answer to say, just don't turn down cool opportunities is my number one lesson.
Yeah, hard things for sure you've been working on. I mean, you're working on Chennai before it was a term, I think. I mean, that was in 2015, so almost 10 years ago. So yes, cutting edge. But what we'd like to know is that if you go from cutting edge, it's so deep to come up for air when you're talking to people in government and your current position at the commission. So how have your technical skills been essential in your strategic and leadership positions?
So again, it's that overlapping experience skill set. And so I am not the most experienced person in policy. And I am no longer one of the most experienced people in AI. The person who builds AI models 60 hours a week, they're going to have more cutting edge technical knowledge than I am. But the thing is, I have tried to do a lot of these things on both sides. And so when my AI colleagues or biotech colleagues say, oh, why doesn't government just move faster? I'm like, that's not how it works. So if you think of it this way, the Department of Defense, Department of Health and Human Services, their annual operating budget, the money they spend is the amount of entire industries. So when you think about moving the total market cap of industries every year, it doesn't just happen on a dime. Or on the flip side, when I have a lot of conversations with my colleagues in policy who are worried about, for example, what is AI going to do to our ability to do bad things with biology? I have long-term, deep practitioner level experience saying that's not actually possible. It's easy to say, and it's easy to think about, but it is not physically possible, technologically possible today. Or that's not actually how it works. So, Karl, earlier, your comment about biology is hardest to do in the real world. No matter how good a computer says you have some scary new design, that's not the hard part. That's not the long pole in the tent, oftentimes. So my technical expertise is invaluable in these conversations. And this is one of my angles to bring to the commission cadre is that I have built these models. I have struggled with these things on the AI side. And then if you think about each of the other commissioners, they have their own deep technical expertise. Mike Daub, who's another one of our commissioners, was the comptroller, the CFO for the Department of Defense. Talk about someone who understands the deep technical process of federal budgets.
Wow.
That is an expertise I will never have. But that deep understanding then to helping write policy, it's because, well, that policy would never fly because of X, Y, or Z. I'll give you the 15 ways they could ignore that policy. And that only comes from this expertise. And so each of the commissioners have this kind of expertise. You know, Eric Schmidt built Google. Angie Belcher has been leading science and being an entrepreneur out of MIT for years. Paul, who's another one of our commissioners, spent his career helping write legislation and get bills passed on the Hill. So the deep technical understanding of the inner workings of Congress, that makes it invaluable when we have these bigger conversations around what do we do and how do we actually get it done. And that's actually why I bring it back full circle again. Why I started bioeconomy 5 years ago is because there's a lot of people with deep technical expertise who have a hard time tying that to high level action impact. And that's why I've been blown away at the staff and the commissioners and our ability to tie the most minutia to big thinking.
This is probably a naive question, but is there any equivalent to the commission that's associated with other emerging technologies, or is it only around biotech?
No, there absolutely has been. So the first one of this flavor was called the Cyber Solarium, which focused on cybersecurity. Then there was the National Security Commission for AI, which Cyber Solarium happened. And then 4 or 5 years later, we had some of our major cyber attacks. The National Security Commission on AI happened. And then 4 or 5 years later, ChatGPT was released. So we have a lot of conversations around what is our version? What is the biotech version of that? ChatGPT revolutionized AI. SolarWinds showed that cybersecurity vulnerabilities were everywhere. What is biology's thing? What is our ChatGPT moment for biology? But I think that is roughly 4 or 5 years lag after one of these big commissions and that aha moment. So we're hoping to find that threshold responsibly.
And when was this commission started?
We officially launched in March of 23, so last year. And we had our interim report that was released in December. We have our final report, which is a collection of our deep thinking, and legislative recommendations and policy recommendations will come out sometime in early 25.
So you guys wouldn't think that the response to the COVID pandemic, especially on the vaccine development and biomanufacturing side, would count as our ChatGPT moment?
I certainly wouldn't discount it as a ChatGPT moment. I think that the ability to produce a vaccine in under a year with a technology that has never produced a vaccine before is mind-blowing. So that might have been, but I think that for me, the way that I think about these is the rapid democratization of the technology. So ChatGPT, everyone, now there's 1,000 competitors to ChatGPT, and everyone can find their favorite AI tool anywhere, versus before it was specialized in Google and Microsoft and NVIDIA's products and things like that. Now, cybersecurity, everyone is aware that there are cyber vulnerabilities and things like that. The pandemic absolutely brought biology to the forefront of people's minds. In my mind, it was still in the health area, and biology is health plus so much more. And we haven't had that aha moment for everyone on the so much more. The grow everything aspect, we haven't had the ChatGPT moment for that.
Yes, we can't wait for that to happen. And when it does, we will have those people that participated in on the podcast. Yeah, I mean, it's very interesting. You mentioned that you guys at the commission written a report and you'll have something coming out in 2025. So we'll also link that to the show notes if I'm sure that's public.
The interim report is publicly available, yes.
Mm-hmm. Yeah, so we'll be sure to share that in the show notes. But what would be helpful for our listeners to know is at least your perspective on what are the potential security risks and the benefits of biotechnology from your role. So any specific examples that either you mentioned in this report or that you want to share, just to help us think beyond pathogens, what are those specific stories that we need to wrap our heads around? Because earlier said it's safe, it's nothing to worry about, but clearly there are things we have to worry about. So if you could give us some stories to help think about the potential security risks.
Well, I think that pathogens will always be one of the largest ones. The world had their painful aha moment with COVID for pathogens. I think that some of the other areas that are concerning are environmental release, so the impact on ecosystems. I'll give you, so it's another pathogen, but I'll give you one that most people don't think about. There's a fungus epidemic going on in amphibians called Kittredge, and it's killing 10 to 20% of amphibian populations a year. And that is an impact that the environment will suffer as amphibians disappear. So it's not in the same kind of human health immediate, like direct, but there is a indirect effect of that. And so the environmental release of engineered organisms is one of the risks that I think that we need to be very deliberate about, because it's no longer just in drug development. If people are engineering something for bioremediation, a lot of the interesting things I've heard in the remediation story, can we use biology for PFAS and PFOA cleanup? I think that would be amazing, but we have to be very careful about putting an engineered organism into the environment. One of the areas that is concerning from an engineering risk standpoint is we're seeing that it's becoming easier and easier to engineer the production of toxins into these organisms, right? It's a chemical, smaller molecule. And so I think that's one of the biosecurity risks that is the conversation in the AI space, is how do we put responsible guardrails on these models? The AI Safety Institute is doing some really awesome thinking about this topic. And for anyone listening, there are AI Safety Institutes popping up in countries around the world, and they're really deep thinkers around how do we move forward in a societally beneficial way with AI. I'm sure there's plenty more. Don't want to speculate. I don't want to make up risks. So I'd be happy to share more later.
I'm
Yeah.
stuck on the fungus that's killing the amphibians. Where did it come from? That wasn't engineered, right?
No.
Okay.
That's just a naturally occurring fungus, but it's an issue.
Yeah.
And so there are lots of conservation efforts and lots of conservation programs at zoos and others that have amphibian breeding programs as a way to be able to release healthy amphibians into the population, because it is a major environmental problem.
How do we kill the fungus? That's the thing with biology. It's so complicated, right? Like the fungus might be bad for amphibians. It could be helping something else. If we remove it, is it going to mess things up even more? That's always a challenge when it comes to biology. Think of the life cycle analysis is just so challenging. It is so
right.
challenging.
And you can't just dump antifungals medicine into the water, because what impact does that have on the rest of the ecosystem? It's the interconnectedness of biology, especially natural biology, is one of the challenges and the amazing parts about it.
Yeah. So this morning, Erum and I were talking about the podcast, and I flagged a news item about a human-borne pathogen that is a fungus as well. So when you mentioned the fungus, I thought that was what you were going to mention. I think it's CRS, which is a fungus that is heat resistant, and it's causing a lot of illness among young people. These things are emerging and they're biosecurity related. I think there's a lot for us to pay attention to there. So as we close out this conversation, Titus, the Commission's tasked with both protecting and advancing biotech. How do you envision this dual mission shaping the future of policy in the United States?
It's a long and intentional and deliberate process. The Commission's final report will come out in early 25, and with that, policy recommendations and legislative recommendations. But that is also not exclusive to the United States. We're a U.S. Congressional Commission, but we spend a lot of time talking to and thinking about how to work with partners and allies around the world as well, because biology largely doesn't respect international borders, as we all learned. I think it's the next step in a long-term conversation. The Commission is actually authorized beyond the release of our final report in early 25. We're authorized through the end of 26. And so this will allow us to then continue to work and advocate for getting some of these policies, as many of the policies as possible, into action, and continuing to build collaborations with industry and international partners. One of the things that I personally really hope that it inspires is more of these conversations that are a bit more integrated with the practitioner community. And in general, the broader policy apparatus does a great job of trying to incorporate expert opinions. But one of my favorite programs in the US, at least, is the AAAS Fellowship, which brings people with PhDs and postdocs into policy conversations to have deeply scientific informed policy. And one of the things that we spend a lot of time focusing on is what we call bioliteracy. So how do we help bring better awareness and understanding all the way from K through grad school? And we also include government. We want a bioliterate government. So we think of how do we have information and upskilling and reskilling and training programs, even for our government employees who are making purchasing decisions and contracting decisions. How do we help them understand the trade-offs between something that was produced with biology or not? Is that different? Is it the same product at the end? How do we think about changing and shifting our acquisition policies to be more amenable to those kinds of things? I think that the education component, in the broadest sense of education, is something that we're going to continue to focus on. And it's something that I've been passionate about for a long time with bioeconomy and other things like that. So there's no shortage of work to do. It's not a release our report and hope things happen. It's the report is going to be a way for us to say, this is the culmination of a lot of really critical input from a lot of people. And now it's time to go make it reality.
It sounds like that big, ambitious projects that you're accustomed to taking on, right? Bioliteracy of the population is a challenge. We're all chipping away at it, but it looks like you have all the experience and people around you, and everyone's listening. So it's incredible. One last question, and you touched on this a little bit earlier, but you mentioned the practitioners. So we have a lot of emerging biotech professionals listening to the podcast. Can you give a piece of advice on navigating the complexities of innovation and regulation besides joining that program that you mentioned? That sounds like a really great program, but any advice?
I think the biggest thing is find ways to engage. And that doesn't have to be going and engaging in this with your full-time job. There are lots of opportunities to provide input, to figure out what policy means to innovators. and then provide this is how you actually would do that to help inform policy. So, Karl, you talked about the listening session with DARPA. I'm starting to write a newsletter. There are lots of forums with which to be able to be engaged. And I think that anytime that it feels like policy or regulation gets in the way, there is likely a very good reason for that to be there. At a minimum, it's because someone did something stupid once and we wanted to make sure that didn't happen again. But I have a much deeper appreciation for, quote unquote, the bureaucracy after having been on the other side for quite a bit of time. And it's easy to throw rocks at the castle and say, they're just slowing us down. But in reality, policy is largely just put in place to try to let things go as fast as possible without having to dramatically walk things back and play damage control, because that will ultimately slow progress down in a really serious way. There was an AI winter in the 80s because there wasn't a lot of progress happening. This is not related to policy, but can you imagine if we had a biotech winter? We don't want that to happen. So innovators, just know that civil servants who are out there trying to write policy are doing it in your best interest. No one is there saying, how do we stop it? Everyone's saying, how do we do it so we don't have to stop it? So just get involved.
Get involved. Great advice. Thank you.
Yeah. I think that's a great note to end on, Titus. Thanks so much for taking the time to talk to us today. We'll look forward to hearing more about your progress and maybe having you come back after the commission releases its report.
Yeah, that'd be great. Well, I appreciate it.
Yeah. All right. Thanks a lot.
Thank you.
Okay, Erum, what do you think about this episode?
This episode comes at a great time where there's uncertainty on what policies are going to be in effect in the coming months and how government takes a look at our industry of biotechnology. It was great to hear Titus's perspective and the work that they're doing. In the report that Titus mentioned, it's going to come out early in 2025, and that's when it'll be made public. They are actually working on a report now, and it's due to Congress in December of this year. And that's in accordance with their initial mandate that it's going to be due in December. But this report will be made public in early 2025, and we will let you know as soon as it is public because we'll be one of the first people to read it. I think a big thing that he pointed out that really validated the work that we do, Karl, in terms of Grow Everything is this idea of like science communications and bioliteracy. He gave us a shout out. He thanked us, which was cool. But I think it's everyone doing it. Grow Everything isn't the Karl and Erum show. This is something that we created for everyone else to have a platform to talk about biology in a way that's easily understood, that's exciting, that people can take action upon. The National Security Commission on Emerging Biotechnology, or the Commission, that's what they're also doing. They're doing it from a policy government point of view. We're doing it from an economic business point of view, oftentimes an innovation point of view. We've got to bring all these conversations together. So I'm excited to talk to Titus again, maybe having someone else from the commission on, that's probably a senator or a congressperson, to hear from their point of view as well. And then we can continue having this conversation about what's government's role in advancing biotechnology and the bioeconomy. Because we had this executive order, hopefully it continues and we can continue advancing biomanufacturing to replace petrochemicals. But let's see. Titus is really cool guy. I mean, you guys heard it, but what do you think, Karl? What did you think about the episode?
I mean, I wish I lived around Titus so I could hang out with him. He's super cool. And he said he was in Colorado and is going to be skiing. I know he's a big outdoors person, which I try to be as well. So I really appreciate him taking this more macro point of view through the National Commission. But I think it's also important to look at his background. I mean, he's done some really exciting things. He's been at exciting companies. That whole conversation about being part of the team at Colossal and working on de-extincting the woolly mammoth. That is a fascinating story. And I think we've been trying to get those guys on the podcast because we think it's important for people to understand why they're trying to do it. It's not just like, hey, we can do this. There's actually a purpose for bringing back the woolly mammoth. And earlier we had a spokesperson from Revive and Restore, which is really focused on preventing extinction from happening, but they're also interested in de-extinction. So super interesting topics. But the National Security Commission on Emerging Biotech is very neutral. Their idea is to support the growth of the biotechnology industry, supporting innovation, and hopefully helping the government develop policies that will continue to foster breakthroughs and promote the growth of the industry. So that's what we're all about as well. One thing you didn't mention in terms of what this podcast is about, it is also about the entertainment value of the biotech industry because people do respond to entertainment. And so I think if we can keep it entertaining and we can have fun doing this, which we do, that helps our message and it helps more people understand and we demystify what this industry does, which I think is really important.
I think a lot of that has to do some more special effects, like bing, bang, boom. I think that's entertaining, right? Like the guy from Police Academy. If anybody knows what Police Academy is and listening to his podcast, you're one of us in terms of age. But I really appreciated how Titus was talking about creating biological products. And he used two terms. And I think these terms we should use moving forward a bit more. But to be able to highlight it and emphasize and underscore is the concept of biotic and abiotic.
Yeah.
So biotic being a microbe that's engineered. So it's genetically engineered. So GMOs being biotic. The actual organism is different and we're using that entire organism, whether we're eating it or making something of it, the actual organism is engineered. But an abiotic system is oftentimes what we talk about here on Grow Everything is engineering an organism to make a product, make a molecule, make an ingredient. And that ingredient is a product, not the engineered organism. That engineered organism is a factory and we used it to make something else. And so that's abiotic. So moving forward, when we talk about biotic and abiotic, you guys will know the difference. We can obviously talk about it again and reinforce the definition. But there is a difference when we talk about how we're using biotechnology. It's not just creating new living things. It's taking living things and engineering or setting them up in such a way that they're making products that have different performance characteristics that we were first getting from chemical synthesis or using chemistry to make certain products. But now we can engineer microbes to make products.
Yeah, I think we should probably get someone on here to talk about that a little bit more because INCI, the International Nomenclature of Cosmetic Ingredients, the way I understand it, if you produce something in a microorganism, you need to list the microorganism that you use as a factory on that cosmetic product or that ingredient. And I wonder if that's one of those things where I've heard people say that labeling holds back innovation. I don't know if that's the case, but it is something that I'd like to explore a little bit more because it's fascinating to understand those differences between biotic and abiotic.
I will say, though, just as a caveat on that label is that it's only if there's a certain purity. So if you have a very pure separation of the engineered organism and the end product that it makes, then you don't have to put that organism on the label. But it's a certain purity level, there's still some organism that makes it through into the product, then you have to put it on the label. So that's a good thing for people that are making abiotic products to understand is that the more pure, the more separation you can get from the microbe that's making the end product, the better off you are in terms of the label.
Yeah. And then just one thing as we kind of close this episode out, I wanted to say thank you to James Angus Chandler, a listener of the podcast, and he recommended a book called The Echo Wife. He heard us last week talk about Wild Robot and the Substance. And apparently The Echo Wife is a gory, over-the-top book about human cloning. So I think that should be a lot of fun read. We love it when our listeners reach out and offer suggestions on things we should be reading. So I'm going to add that to my list and we'll see what that's like. Anything else that you want to add, Erum, as we close this episode out?
So what I would like to wrap up with is, like you said, we love when people reach out to us and recommend certain books or content or people to be on the podcast. So please continue reaching out. It's towards the end of the year, 2025 is right around the corner. It's going to be, again, a brave new world, but we're going to be here. Please continue listening to the pod because we're going to stay on top of things as things change for the biotech industry. So stay tuned for that. We're really excited to see how we can continue to innovate. And thanks for listening. Again, follow up, check on the show notes, reach out to us, and stay tuned for the next episode.
All right, that's the pod.